Why do shadows sometimes look blue, red, or even green when we know a shadow is just darkness? That simple observation hides a surprising truth. A shadow is not an absence of light so much as a different conversation between lights, materials, and our eyes. In this video, we will follow that conversation and discover how colored shadows are nature's way of showing us the hidden mix of lights around us. We'll start with a small everyday trick you can try at home. Point a single white flashlight at a small toy on a table. Now bring in a second colored lamp, red, green, or blue, and place it at an angle. Suddenly, the object casts not one but several shadows, and each shadow looks tinted. Why? The answer lives in three ideas: overlapping lights, indirect illumination, and the quirks of human vision. First, overlapping lights. Light adds. Unlike paint, which mixes by subtracting wavelengths, beams of light combine by adding energy. Imagine light like colored fog. When red fog and blue fog overlap, you stand in purple. When two lamps hit the same spot, their colors add together. A shadow forms where one of the lights is blocked. If one of the lamps is red and you block the white lamp, the region sees mostly red light and the shadow appears reddish. That is additive color in action, and it's the simplest way to make a colored shadow. Second, indirect illumination. Outdoors, shadows are never lit by nothing. The sky, the ground, nearby walls, and even foliage reflect light into the shaded region. A patch of grass bounces green light. A brick wall bounces orange. Those reflected rays fill the shadow and tint it. So when you stand under a tree on a sunny day, your shadow often looks greenish because the leaves scatter and reflect green into the shaded area. This is not mystical, it's simple reflection. Third, atmospheric scattering. On a clear day, sunlight scatters in the air and the sky takes on a blue. That scattered blue light comes from all directions. When direct sunlight is blocked, the sky's blue often becomes the dominant light source in the shadow. That's why shadows in daylight often look cold or blue, even when the sun itself is white or yellow. The physics behind that is called Rayleigh scattering, and it favors short wavelengths, blue, being sent in many directions. Now, let's thread these ideas together with an analogy that gives intuitive shape to the whole process. Think of a room as a party. Each light source is a guest with a colored flashlight. When everyone speaks at once, the room's color is the mix of voices. A shadow is like pulling a curtain in front of one guest. You still hear the other guests. The sound doesn't stop. Its balance changes. The same happens with light. Blocking one source doesn't produce silence. It changes the balance of colors that reach your eye. This party analogy also helps explain why colored shadows can be subtle and change with position. Move a lamp and which guest is blocked changes. Walk toward the shaded area and the relative strength of the remaining lights shifts. Your brain then adjusts, and sometimes that adjustment makes the color pop. Next, let's examine what the eye and camera do with these signals. Our vision system is excellent at extracting color from contrasts and edges. Shadows create strong local contrasts, and the color differences at those edges are amplified by neural processing. There is also chromatic adaptation. When you stay long enough in a scene, your brain recalibrates its idea of white. That recalibration can either mute the perceived tint of a shadow or, in quick glances, make it look more vivid. Cameras complicate the story further. Most cameras apply automatic white balance to make the overall scene look neutral. That can reduce or remove colored shadows in a photograph. On the other hand, if you manually set white balance or shoot raw, you'll often see colors that your eyes smoothed over. For artists and photographers, colored shadows are a secret superpower. Painters have known for centuries that shadows carry color information that defines material, depth, and mood. A blue shadow on snow tells your brain that the snow is reflecting a cold sky and that the sun is warm and directional. In portrait photography, using a warm key light and a cool fill creates pleasing separation. The shadowed side takes on the cooler fill, which sculpts the face. Now let's expand to a few striking real-world phenomena. At sunrise or sunset, shadows often look long and red-purple. That's because direct sunlight is reddened by passing through more atmosphere, while skylight still contains more blue. The overlap yields purple edges, red from the sun plus blue from the sky. In city nights, colored shadows can be dramatic and garish. Neon signs, street lamps, car headlights, and shop windows provide multiple colored sources. Block one source and the remaining light gives your shadow an unexpected tint. Underwater, shadows can look green or blue depending on what wavelengths survive the water and what the seafloor reflects. In forests, dappled light under leaves is strongly green because leaves preferentially reflect green wavelengths. In each case, the recipe is the same: multiple lights, spectral filtering, and reflection. To make this tangible, here's a quick experiment you can do with no special gear. Take 2 desk lamps, put a red filter on one and a blue filter on the other. A sheet of cellophane will do. Shine them on a small object from different sides. Now place your hand between them so each lamp is blocked in different places. You'll see 2 or more colored shadows. Move the lamps closer and farther. Notice how the tints change. Add a white lamp and watch the shadows desaturate. Try the same setup outside on a sunny day and notice how the sky's blue fills the parts you might call black. These micro-experiments reveal the underlying mechanics. Additive mixing plus ambient fills equals colored shadows. There's an important conceptual fork here that often confuses people. Colored shadows are not caused by the shadow absorbing just one wavelength. That would be a subtractive process like dye absorbing light. Colored shadows are largely additive or reflective effects. The shadowed region receives different proportions of the available lights, not a canceling of specific wavelengths by the shadow itself. Now for the moment we like to call Eureka. Up to this point you might have been thinking, a shadow should be black, so color there must be an illusion. But the truth is richer. A shadow is a lens into the local lighting environment. It reveals which lights are present, which ones are blocked, and which surfaces are bouncing color around. By looking at the tint of a shadow, you can deduce the mix of light sources near that spot. That is the subtle detective work that artists, architects, and cinematographers use every day to control mood and readability. Before we wrap up, let's connect this to a few practical takeaways. If you shoot photos and want neutral shadows, use a single broad white light or set your white balance manually. If you want dramatic separation, add a colored rim light or use colored gels for fill to introduce purposeful tints. Painters, do not default to gray for all shadows. Instead, ask what is illuminating the shaded area. Sky, foliage, reflected light from a wall? Let the shadow convey that information. Designers and architects, colored shadows can make spaces feel warmer, cooler, closer, or more mysterious. Lighting choices are not just functional, they are semantic. Finally, here's a neat thought experiment to leave you with. Imagine a scene lit only by 2 lights, one saturated blue, the other saturated yellow. If you block the blue, you will stand in a yellow shadow. If you block the yellow, you will stand in blue. Your shadow's color is a direct map of which light is missing. In other words, a shadow is like a fingerprint of the lighting setup. Understanding that fingerprint gives you a key to read scenes you thought you already knew. If this little journey rewired what you thought a shadow was, then mission accomplished. If you want more visual hacks that reveal the hidden mechanics of everyday physics, hit like, share this with a friend who notices strange colors in photos, and subscribe to How It Actually Works for one clear visual explanation every week. We unpack the tricks that make the world look the way it does, and we give you the keys to see them yourself.